Let's get started, and the others will join meanwhile. So good morning, everyone. This is your day 12 or 12th day of the JS course. Can you hear me, by the way? Can you see the screen and can you hear me well?
Yes.
Okay, cool. Thank you. Right, so we have only one day left. Well, as per the plan for the JS course, and both today and on Monday we'll be doing promises. Again, promises promises are a very important part of JavaScript, of the modern JavaScript, because that's how we do asynchronous stuff. All your Node.js functions can return. There are options, couple of options. They can accept a callback function. They can return promises. However, usually we developers prefer to work with promises as much as possible. So we try to avoid callbacks also as much as possible, because they lead to the callback hell and having a hard time wrapping our head around how callbacks work. Yeah, the order of execution, etc., etc. So today's plan is to maybe write a function which does some kind of where I will simulate an asynchronous job, but with the callback syntax, right? And I will convert that callback asynchronous kind of function into the one that uses promises. So that you see how that transition is done. In the current days, you usually do not do that. Again, pretty much all the libraries, all the tools, frameworks, they usually natively support working with promises. Whatever you do with them, they usually return promises, right? Maybe some very, very old libraries, packages, which did not transition to promises, they still work with callbacks. However, again, promises is the modern way of doing asynchronous stuff. So very important to learn how to work with promises. Now let's go to the code editor, and let me start a project here. Okay. So now I'm going to create a function which is called do work. Okay. And what this function does, it accepts a threshold value. Again, we're going to use the math random to decide either we're kind of throwing an error or returning a success value. So I'm going to say that the first argument of this function is threshold, which is a number. So we're doing TypeScript stuff here. And the second function, and the second argument is the callback function, callback function. And now this is a function which returns nothing. Okay. So, right. So since I'm not going to do some kind of network request, or I'm not going to read some file asynchronously, I have to somehow kind of simulate the asynchronous work here in this function. Sorry. And since we know that we have set timeout, which has the web API, which is a web API, and there is a callback queue, which is different from call stack. So all the kind of synchronous code will be put in the call stack. And when the call stack is empty, then the callback queue, then the callback schedule in the callback queue will be executed. So whatever we do in set timeout will be basically executed after our synchronous code is done. Hence, we will be able to kind of simulate an asynchronous input output here. So I will do set timeout, right? And the first argument of set timeout, if we recall, is the callback function, which will be put in the callback queue. And the second argument is the delay in milliseconds. Okay, so let's do this way. I'll check if math.random is less than threshold, right? And if it is, I will call the callback function with the first argument of null and the second argument with success. Now, this is, yeah, so error and value. Right, so I updated the API or kind of the synopsis of the callback function here. Okay, so what does this mean? Let me write the else statement, and I think you will understand what the null or what the first argument stands for. So if we are strictly less, if math random is strictly less than the threshold, we call the callback function with the first argument of null and the second argument of success. Okay, so what if the math random is greater than equal of the threshold? So in that case, we call the callback function with new error, right? Exceeded the threshold. Now we're going to say and I'm going to pass null here. Exceeded, yeah, I have a typo here as usual, so let me exceed it. Yep. Okay, so now as you can see in the else statement, I passed an error as the first argument, and I passed null as the second argument. And in the first case, I passed the success message as the second argument and null as the first argument. Now, in the JavaScript world, this actually comes from the Node.js world. However, it got kind of spread also in other places. So usually in JavaScript or Node.js code, the very first argument in your callback function is your error. So that's a notation. That's kind of an agreement that the first argument in your asynchronous callback functions is always the error. And if error is a truthy value, then you have an error. If that first argument is not a truthy value, then you do not have an error. Then you can process whatever there is in the value. So that's exactly what we did. Now, again, if math random is less than threshold, this is a success case. So we return, so pass null as the first argument, and the first argument is the error as per the synopsis of our callback function, and we pass the success string as the second argument. So this is the success case. Now, in the else statement, which is the error case, we pass an instance of an error. So this is the error kind of instance, and the error message is exceeded the threshold, and we pass null in the value itself. So okay. So of course now this function does nothing because we did not invoke the function. Now let's go ahead and say do work. And I will say 0.4, and then as you can see, my TypeScript already kind of tries to help me here. Okay, so what I can do here, I can even strictly type my arguments. I can say It can be either string or null. If I say number or null, I will hopefully get an error, right, on the line 11, because TypeScript will say string is not assignable to a number, because in the definition, in the TypeScript definition of this callback function, I said that the value is of type of either number or null. However, I passed a string, so I can strictly type and say string or null, which will cover only this, which will cover both of these cases. And if we would pass anything else, like a number, TypeScript will say that's a problem. Okay. Now with the error, we can say error or null. So the same thing here. If I would pass the string message here, just a string here, now TypeScript will say string is not assignable to error, right? Because we said our argument error is either of type error, which is the error interface, error class, or it is a null. So again, to cover both of these cases, and anything else will fail. So if I would pass 1 as the error, again, TypeScript will complain, which is good. So we strictly typed our callback function. And since the callback function does not return anything, and even if it did, we usually don't care about that. So usually callback functions do not return anything, hence the void here, which basically means the function returns nothing. So that's that. As you can see, we don't store the value of this invocation of this function call. We just call the callback function with the values we need. Now, when I start typing in my editor, as you can see, TypeScript starts to help us out, as it can say that this argument is a callback function, which has 2 arguments. The first one is error, the second one is value, and the first one is of type error, and the other one is of type string. So I can say error and the value. Now, when I return 1, still nothing happens, but there is no need to return anything from this callback function, because again, we don't store the return value of callback function. So we do not need to return anything here. We just need to process our values here. Now, the way you do error processing in your callback functions, so since we might have an error, we might have or we might not, depending on the case, we need to first handle our errors. So the way we do that, we say if error, if there is an error, right? So we know that our error can be either of type error or null, right? So if we say if error, then it is this case. So we're covering the error case, which is what we need. Now, if there is an error there, we do not need to do anything. We simply kind of throw the error, right? So we continue, sorry, we do not return, but we throw. So this means that we kind of continue passing the error up to the chain, right? And if we come to line 23, if we are on line 23, then there was no error, and we can do something with the value. So we can console.log the result. No, sorry, the success message. Rather, there was no result in their value. So now, when I save this file, I saved the file. Set timeout started working immediately, right? And of course, there was a 2-second of delay, so that's why we did not see anything in the terminal right away, because we had a delay. And after 2 seconds, as you can see, we exceeded our threshold, which means the value of math random was greater or equal to our threshold, and we received, and hence we generated this error. Okay, so that's these lines working, right? So we have the error. Okay, and if we save this, we'll be able to maybe see the success case. Okay, so we were lucky in this case, and math random was strictly lower than our threshold, and hence we've seen our success message. So this is again basically how you would work with callbacks, right? So our function do work does something asynchronous. It accepts some arguments to do the work, whatever arguments there are. It does not matter. Usually the way asynchronous functions like do work, they accept the callback function either as the first argument or the very last argument. I think that the idea there is to have the callback function as the last argument. Usually that's what I've seen. And these callback functions usually, again, coming from Node.js, accept multiple arguments, or rather provide multiple arguments, sorry. And usually the first argument is our error in case there is some kind of error during that asynchronous processing or whatever. In our case, it's line 13, right? So and the way you usually do your asynchronous, the way you usually process your errors and values in your callback is you first take care of this error case, and then you do take care of the success case. So now we can again call our do work function now and say 0.4 and 0.5. And we will have error 1, value 1. So I'm again calling our do work. And again, what I need to do, I need to first process my errors. And then what I need to do is process my success case. Okay. Now, as you can see, what we have here, what this code basically means, it means do some asynchronous stuff, right, before this first asynchronous function is processed. So whenever the first asynchronous job is finished, do another asynchronous job. And to do that with callbacks, we will have to kind of nest these asynchronous calls in each other's callback, because there is no other way to kind of guarantee that that the first asynchronous job is finished. So the only kind of way to guarantee that this first do work on line 18 is finished, it's doing something in its callback function, because this callback function is called in the asynchronous do work function when we have the result, right? Otherwise, it's not called. So having this function or doing something in this function is the way of processing its results. So when we want to do another asynchronous thing after the one on line 18 is finished, we will have to start that asynchronous thing inside of its callback. I hope this makes sense. Okay, and of course, as you can see, what happens is that in this first do work call, which is on line 18, we are occurring some errors, and hence, since we are throwing an error, we do not continue with anything else. So this part does not work. So let me maybe increase the threshold here to have maybe slightly more chance. Okay, so let's see. Okay, so now this do work processed, did its job. It returns success message. And so this is the success message of the first call, right? So the messages are different, so that we can see that these are actually different kind of things. So, and as you can see, we also have another thing logged in the terminal. That's the error we have here. So, and now if we would like to do another asynchronous thing inside the second do work call, which is line 25, we would have to again kind of duplicate all the stuff right here. So, and now as you can see, our do work function calls are being nested and nested and nested. So again, this is the pyramid of doom, right? So we're continuing to nest one into another because we need to do one asynchronous job after another, right? So, for example, the second asynchronous job is based on the output of the first one. So we have to kind of have the result of the first asynchronous job and then use its result to start the second one, and hence we would have to kind of nest all these asynchronous jobs inside one another. And as you can see, we have a recurring theme here. As you can see, we are handling our errors on the on the first as soon as possible. However, the problem here is that this is, can you see how repetitive this is? So we're basically writing the same code over and over and over again to handle our errors. So if we, this is one of the other problems of doing asynchronous stuff with callbacks. So you would have to kind of repeat all these if error throw, if error throw, if error throw. So it's super repetitive, and yeah, one of the problems, not only the callback hell, not only the pyramid of doom, but also having this thing repeat and repeat. And if you have 5 asynchronous function calls nested in one another, you will have these parts kind of repeated in all these 5 places, because you should and you have to handle your errors. Otherwise, your program might just end unexpectedly and cause issues for the user. So you should handle your errors. Of course, what I do here, I simply throw the error up in the chain. However, you might do some other error processing, show some kind of message, whatever it is. So you can imagine that the logic in this if becomes bigger and more complex, and imagine doing that in 5 places and nesting them in one another. So that's why we have this idea of pyramid of doom. Okay, so let's have some maybe I don't know, 10 minutes of break, and we'll try to convert this function, this do work function, to work with promises, and we'll see how the asynchronous flow becomes different from this. Okay.
Okay, thank you.
Cool. So let me start the timer. And okay. Cool. So can I somehow wrap the lines, or how does that word wrap? Yes. Okay, better. So that you can see all the code here. And also maybe like this. Okay. So let's imagine our task is, given this function do work async, which does something asynchronous, as the async part of the name of the function, in the name of the function, tells us. It receives a callback function. So we have this old way of doing async here. So given this function do work async, we need to convert it into the promise option, right? Okay. So now let's recall again what a promise is. So a promise is something that we can represent our asynchronous work with, right? So it's a concept, another concept which represents some kind of asynchronous things in JavaScript, whether that's a network call, whether that's I don't know, whatever it is. We can represent asynchronous things with promises, and promises were created partially to solve this this issue with pyramid of doom, etc., etc. But they don't solve only that. So it's kind of nice bonus of solving this pyramid of doom, also this error handling, as we'll see soon. So as you recall, when you create a promise in the very beginning, so promises have states, right? So as you recall, in the very beginning, the state of the promise is pending. Then it can transition from the status of pending into fulfilled, right? And it can also be rejected. Okay, so if it's fulfilled, it means there's a success case, or like if we pass this if, then we do something with our value. So this is our success case in the case of callback. Now, in the case of promises, if the state of the promise is fulfilled, then it's the success case. Now, promise can also be rejected. That's the error case, which in the callback function is this if, right? So if error, then do something. So that's the error case in the callback function, and in promises, it's rejected. So you now having only promises does not do anything, right? So you have to do something called consuming promises. So if you have a promise, you can consume the value of the fulfilled state with .then, right? And .then receives a function, and the argument of that function is the value of that fulfilled state. So we can do a console log of that value, right? So .then console log value is like console logging here in this callback when we pass the kind of error handling. Now, when the state of the promise is rejected, we can consume the value of that rejected promise with .catch, and usually that's some kind of error object or error message, whatever it is, console.error, error. So so again, with .catch, we consume the rejected promises value, which is usually an error message or an error object, and with .then we consume the fulfilled promises value, and that can be anything. So that value can be anything. Now again, .catch is very similar to this if part of the callback, right? So when we do if error, throw error, or handle the error, or we can say to keep it similar, we can say return console.error, and why return? Because we do not want to process any other code if there is an error, hence return. So we don't need to console log the value. If there is an error, the value will be null anyway, so we don't have to process anything, hence the return here. So yeah, .catch error console log error is similar to this if in the callback, right? So if there is an error, then do something, then process that error. And .then value console log value is similar to what we have on line, for example, 28, right? So when we are on line 28, since we have a return on line 25, if there is no error, we will pass this. If there is an error, we will return. So we will never get to line 28. If there is no error, which is the .then case of the fulfilled promise, we will then appear on line 28, where we can process our value, and in this case, I simply console log the value as on line 20 with promise. So I hope you're starting to see the kind of the way promises and callbacks works, right? So they're kind of similar. I'm trying to show the way it's done in promises and the way it's done with callbacks. So again, if there is an error in the promise, you should consume that error, right? So if you just say promise, the actual asynchronous thing, yes, of course, will happen, right? You create the promise, you I don't know, do some HTTP request, whatever it is. That process, that asynchronous process will happen. However, you will not be able. So again, it's like the same if I would do. It's the same if I would do this, right? So let me just maybe remove all this. It's kind of just saying promise is kind of similar to this, right? So I say do work async, pass a threshold, and then pass an empty function, which means the asynchronous job will be done, right? the set timeout will work, etc., etc. We will wait for 2 seconds, and the callback function will be called with either success or error. But in this case, we passed an empty function, which does pretty much nothing. So we will not see the result of our asynchronous job. Hence, we had to write some meaningful code here to process our error and our value, and yeah. So that's that. Now again, with promises, when you just say promise, it is very similar when you pass an empty callback function to your asynchronous do work async function. Yes, you can just say promise. The asynchronous process will happen as with do work async, but you should consume the value of the promise to see the result. As with the callback function, you will have to write some code to process your error and your value. I hope this makes sense. So the way of consuming the promise again is the .then, and the way of consuming the error is .catch. Now, so again, yeah, we're recalled how promises work. So let's maybe go ahead then and implement these same kind of let's implement the version of this do work async which works with promises. Okay, just give me 1 sec. Okay, now what we do, we say function do work Promise.fied. Okay. Now the way this is going to work, we will say we will pass the threshold again. And now there is no changes there, right? Because our original asynchronous kind of function expects to receive a threshold. So we will have to also have that threshold in the Promise.fied version. However, now what we do, we say we should return a promise for this function. Okay, so we're trying to convert this callback version of do work async into another one which works with promises. So we should return the promise, and that's where we start. Well, we return new promise. And as you recall, our promise constructor receives a function, and the first argument of that function is the resolve function, which will get the success value, and the second function is the reject function. Well, conceptually, it's resolve and reject. Again, you can name these however you wish. You can say res, you can say reg. It completely doesn't matter. Again, I like to name my things semantically. So I will say resolve and reject. Now what we need to do here, we need to somehow call this do work async function and process its output, and somehow using the resolve method and the resolve function and the reject function to kind of resolve or reject our promise here with the either success message or the error message. And okay, so you just do it exactly as you spell it, right? So now we need to do our asynchronous work. So we start with that. And since we receive, since we have the threshold argument in the do work Promise.fied function, we simply pass that. And now you might ask, so where the callback function comes from? Now we write the callback function here. We say error, right? You might have expected that I would pass the callback function here, but I'm not going to do that because we are now working with promises. We will not be working with callbacks in the Promise.fied version of this function. So we will need to implement that callback inside this do work Promise.fied function. So now what I do is I say error and value. So I implement the callback here because the user, whoever uses this function do work Promise.fied, should not care and does not care about the callback. So hence I'm going to implement this inside that function again, they don't care about the callback. Okay, so now let's again start processing the error case, right? So if there is an error, now what we do, we return reject error. So what this will do, this will call the function reject a foreign promise with the error, which means the status of our promise now will be rejected. So we will get a rejected promise where we have our error, which is this. And that seems to be correct. Now, what we do next, we simply need to resolve our promise or fulfill our promise with the success case. So what we do next, we simply call the resolve function with the value. Okay, I hope this makes sense. So we implemented our custom our callback function here. And again, since we're doing promises, we have this resolve function and we have our reject function. Now, our callback function gets two arguments. The first one is error, the second one is value. Now, if there is an error, we should reject our promise with that error, hence these three lines. And if there is no error, we should resolve or fulfill our promise with the success value, hence this resolve value call. And that's actually pretty much it. Now let's maybe say do work promissified 0.5, and I'll say then value console.log promise success value. And of course, I should not forget to process the error case here. Because we can also have our promise rejected with the error. So I will have error here, console.error, promise error, and sorry. So now when I save my file, I hope I will not get any errors. So in 2 seconds, we have our promise resolved. Now let's save it again to get the try to get the error kind of okay. So now we've seen both options, right? So in one case, our promise was resolved with the correct value, and now in the second case, promise is rejected with another value. And okay, so this seems to be working, and as you can see, we converted our do work async function, which expects to receive a callback. So it's the archaic way of doing asynchronous stuff. So we converted into the modern way of doing promises, of doing asynchronous stuff, which is with promises. And we had to, so we have our threshold passed in the do work promissified, and we implemented our own kind of callback function inside do work promissified, because the user does not care about callbacks because they are doing promises. So there is no passing any callbacks. Usually there is no passing callbacks with promises. So that's the whole point. We should not have callbacks with promises. We simply expect our function to return a promise on which we can do .then to consume the success values, and the .catch to consume the error values. Okay, so so now what if I would like to call, what if again I would like to do this asynchronous job multiple times, right? So in this case, what we've done, so let me maybe grab the same arguments, right? So what if I would like to kind of write an analog code of this, right? So we have the callback option here, and now my task is to rewrite this with promises. And since we have the promissified version of our callback asynchronous function, now we can do that. Now, okay. So in each our callback, as you can see, we console log our values, right? And then we individually process the error. So if we have 3 asynchronous callback functions nested in one another, we have 3 places where we do if throw, whatever it is. So we do that 3 times. But now we'll see that we will do it only one time, only once. So okay, so this first job has finished processing. Now, what we can do the following. We can, of course, still console log our value, right? Promise success value. And now what we can do here, we can return the other kind of asynchronous but promisified version, which was 0.5. And now what we can do here, so we did dot and on the dot do work promisified 0.7, right? So here we consume the value, the success value of do work promisified. We console log, and then for some reason we return another call of do work promisified 0.5. So again, I'm trying to rewrite this with promises. But why did I return these do work promisified 0.5? Now it turns out when you return something from your .then function, you can write another one immediately after that, as I have shown yesterday, and you can say promise success 1. Okay, so now the value of the second then will be the value of this call, not this call, because we returned another value or another promise. If I would return 1, the value here would be 1. But I'm interested in returning another asynchronous thing here, this one on line 49, do work async 0.5. So that's what I'm returning here. Now, when this is resolved, if this is resolved, because as you remember, we can also reject our promise. Now, when this is resolved, and if this is resolved, we will also have our value in the second then. That's why we have now a console log here. And of course, if we are in the .then consumer, we know that this is the success. Okay, so there is no errors here. Everything is okay, so we can consume our value. Okay, now what happens next? We now we pretty much do the same thing, okay? And with the last value, which is 0.4. 0.4. So again, we returned another promise from the .then. We returned another promise, and the way to consume the success value of that promise will be to write another .then. Okay. So this is the whole benefit of promises. You can return promises, values, whatever it is from .then, and write another .then immediately after that, and that .then will await for promise. And when you are in the callback of that .then, you have a guarantee that your promise is resolved, or you have your whatever value it is. So this is the whole kind of benefit of promises. Okay, now as you can see, we do not indent stuff here, right? So we do not nest our things here. Everything is on the same kind of level of indentation, right? And however, with the asynchronous stuff, as you can see, every time we write one more asynchronous job, we are nesting one more level. So 1 level, 2 level, 3 levels. Imagine you have 5 asynchronous jobs to do sequentially. You will have 5 levels of indentation. So again, pyramid of doom, crazy stuff. And now we have our promises, right? So we can write .then on the promise, process the success value, return another promise from that .then, and then process that promise's value, and then return another promise from that .then and process the value, the success value of that promise. Now, of course, you could have done this. Okay, no one kind of holds your hand to do this. .then value, console log value, and of course you could have done this. .then value, console log this. I could have removed all these. Okay, but now of course you can do this, but now what we have come to is again nesting our promises inside one another, which completely doesn't make any sense because well in this case, right? In this case it completely doesn't make any sense because we again come to the same pyramid of doom. We nest our promises inside one another. So we have dot then, but then we then we call our promise in that dot then. We write another dot then on that call, and then in the callback function and in the processor function of dot then, we write another dot then, and then continue nesting and nesting and nesting. So we come to again to the callback version and pyramid of doom, which usually doesn't make sense with promises. So this is the incorrect way of doing promises. So I'm just showing this that you know that this is the incorrect way of doing promises. This is not what promises are for, because you again come to the same type of callback style things, and now in this case you would have to write dot catch statements everywhere, error console.error. Now you would have to write this dot catch everywhere, so it's really kind of an analog version of this thing which we actually wanted to escape. So, but again, we used promises in an incorrect way and came to the same idea. So no point of doing that. So what you should do, you should do this. What you should do this. If you need to process some promises in chain, just return your promise from the dot then, and on the next line when you write another dot then, that would be kind of the result value of whatever you returned. So if I would just do return 1 and return 2, again this might not be this might not only be promise, it can be kind of anything, right? So if we return 1 or 2, let's hope this first one is resolved with, okay, so let me do this, promise.resolve 0. Yeah, so I just use promise.0 to start a chain of fulfilled promises, right? Because I need the dot thens to be called. Hence, I used promise.resolve just to kind of simulate, just to show this part. Now, again, what we have in this first dot then, we have console log promise success 0, which is correct because the first then, the value in the first then represents the fulfilled value of our first promise, which is 0. Now we'll return 1 in the first then, and in the second then we have promise success 1. It is 1. Now again, it could have been a promise. I could say promise.resolve 1. Okay, this also works. This is kind of pretty much the same. So promise.resolve is a promise. It resolves to value 1, as you can see. Dot then kind of unwrapped the value for me, and still in this argument value I have 1. So I don't have promise 1, but I have the actual value 1. So I can either return 1 or promise result 1, doesn't matter, because the promise will the dot then will identify. If it's a promise, then it will give you the value, the result fulfilled value of the promise. If it's a primitive value like 1 string, well, not a primitive value, but the value which is not a promise, it will just simply give you that value. So in the second dot then we have promise success 1 and value, and as you can see it says promise success 1 in the terminal. And we return 2 from this then, and on the last one, which is promise success value, now we returned 2 here, and hence the value of this last dot then will be 2, and that's why we have promise success 2 logged in the console. So I hope this all of this makes sense. Again, I've shown the correct way and incorrect way of using promises. The correct way, again, is to try to return promises from your .thens and do your work there, because you then escape the pyramid of doom issues, right? All of our .then calls are in the same level, right? So we were not kind of continuously indenting .thens into another. So we've already solved one of the major issues with callbacks. The second major issue with callbacks is that with callback asynchronous functions is that in each asynchronous callback function, you handle your errors. So we have three kind of calls here, and we have three if throws. And now in this case with promises, we can just have one single .catch in the very end of our chain, right? Of our promise chain. And whenever any error is thrown here, here, or here, will be catched by this. So you handle your errors in one single place. Of course, you should kind of not forget to put that .catch. If you don't put this, there will be an unhandled promise rejection. So we have a success here. Let's try to save it one more time. And yeah, so we get our error, and this error is not handled by anything. So we should have our and it was not handled by us, because if let's save it one more time. And one more time. Cool. So the first promise resolved with a success, and now the second promise, which is this one, rejected. And hence, as you can see, that error was catched on line 44. Why? Because we see promise error and the error itself, which is this line. Okay, so this is the way with promises to handle your errors. You write your .thens, you return your values, your other promises from your .thens. You do not indent them, you do not nest them in one another. Otherwise, you would neglect the whole value of promises themselves. And then you have one kind of catch statement in the middle, on the very end, to handle all the errors. Now, of course, you can have multiple .catch calls, right? So we can have .catch here, and this one will kind of handle errors in these lines, right? So whenever an error here in the first one, and there is an error in the second one, we will kind of handle our errors with this first catch. Now let us see if we have any error thrown. Okay, success. Okay. Oh, now it's not going to. Very good. Okay, finally. Cool. Now, as you can see, the error in this, let me see, was it the first one? Okay, I cannot tell. So there was an error either in this first call or this second promisified do work call. And as you can see, that error was handled by line 36. Why? Because it says promise error 1 and the error itself. Now, strangely, what you have also seen was there was some other console logs, right? Like this one, promise success undefined. So, okay, so it means we are on these lines, but isn't that strange that we have an error and for some reason we are somehow continuing with the success case? But that kind of doesn't make much sense. Okay, so that kind of seems strange. Now, the problem here is that when you have a catch consumer in the middle of your thens, you would have to make sure that your error is kind of propagated further. So you can say console error of that error, but then you will need to also return your error, because .catch works similar to .then. If you return something from .catch, it will be kind of propagated further, or we can say throw rather error. right? So as you can see, promise success one set undefined, which kind of suggests that the argument value on line 41 had an actual value of undefined, which is kind of correct, because I rolled back the code, because what we had on line 36 is a catch consumer and a function. And the first argument of the function is error, and what we return here is whatever console.error gives us, which is an undefined. Hence, the value in the line 37 will be undefined. So this is one of the things which might seem not natural. That's why, remember, if you have a .catch consumer in the middle of your .thens, just remember that you need to rethrow your error in .catch. And this is kind of similar to this if return, if throw part of the async, but this is only the case when you have your catch consumer in the middle of your thens. Now, if you have your catch consumer in the very end, that's kind of okay. You will not have any other, you won't have that kind of issues. But if we would put another .then here in the very end, the same kind of error would still be there, because console.error returns an undefined, and this .then will receive that value undefined. So in that sense, .catch works similar to .then. Now, if we save this, let's see if we get a, okay, all of these are success. Okay, so what is the probability that all these promises return success? That's funny. Let's save one more time. Success, error. Okay. Now, what we have here, we prevented the chain to continue. Now, let me explain the result here. So we have in the terminal promise success, which is line 32. Okay, that makes sense. Now we return another promise, and we have a catch consumer on line 36. Now, as you can see, promise error 1 was called, meaning that there was an error here. Okay, and but now the difference is that we just don't console log and return undefined, but we rethrow our error. Okay, and that means that effectively these two .then consumers will never be called, because we rethrowed our error. We said that, okay, I've processed my error here in the middle of my promise chain, but this is an error, so I want you to propagate it further, and I don't want you to call these .then consumers, which are intended to process your success cases, and we're not in, and this is not a success case. This is we have an error, so we should throw the error further to avoid of having these two .then consumers run. And as you can see, nothing is logged in the terminal furthermore. And in the previous case, as you remember, we had promise success 1 logged and undefined, which means the value argument on line 41 was undefined, which means that after we actually continued the chain after .catch. However, we had an error there, and we should not have continued the chain, so we now prevented that. So again, very important thing, remember, if you have a .catch consumer in the middle of your chain, in the middle of your promise chain, usually you should also return your or throw your error in your catch handlers to avoid these .thens being called. Okay, so since we have spent quite a lot of time on this second point, so we basically reviewed what promises are in a few words. We've written an asynchronous function, an asynchronous callback function, and converted that into promises. We have seen how to use promises then correctly, in a correct way, and in the incorrect way. Now let's talk about a few. Okay, I have Promise.all.settled here, but maybe I'll not talk about this. I'll show how Promise.all works and Promise.race works. And yeah, we'll see if we have time for Promise.settled. So now let's talk about some other static methods on the Promise class, right? So the first one is Promise.all, and the second one is Promise.race. Now, again, from all of these, actually, I've used Promise.all. I actually use it all the time. So learning what Promise.all is a very important tool. It's a very important tool you should be aware of, and you should be able to use it. I actually haven't used Promise.race that much. Sometimes I'll explain what it is, and if you ask, so what is the use case for that? I just cannot come up. Maybe I will be able to come up with a use case, but I've never used it practically in any of my projects. However, I use Promise.all all the time. So I will start with Promise.all, and we'll just kind of skim through the Promise.race, how Promise.race works, and we'll see if we have some time left. We'll also talk about Promise.settled. Okay, so I'm going to comment out all this code. Now I'm not removing this code because I'll be sending this to you. I'll be annotating this code with some comments, because this is an example. I want you to learn, to look at that, to see how the asynchronous callback function was converted into a version which returns promises, and how to actually work with promises here, and how would you work with the callback functions, and to just simply visually compare the differences between the two approaches, and hopefully see that the permissified version is just better. It is just better. Okay. So Promise.all. Now we are already aware of a couple of static methods in the Promise class. The first one is Promise.resolve, right? Which creates a resolved, a fulfilled promise. And the other one is Promise.reject, which creates a rejected promise. So you cannot do .catch on the first one, and you cannot do .then on the second one, because the first one is always fulfilled, always resolved. So you will get the value of 3 in this case in the .then consumer, and you will never be able to use the .then consumer on the reject. I mean, in the normal way, and because this Promise.reject is a rejected promise, so you can use .catch on that. Okay, so we already knew 2 kind of static methods on Promise. Now the third one would be Promise.all. Now what Promise.all receives, it receives an array of promises. Okay, so it receives an array of promises. Let me bring this resolve here, and then let's get rid of the reject here. So I'll say 1, 2, 3, and 4. Now, again, Promise.all receives an array of promises. Now, how does this all work? Now it returns a promise. Promise.all receives an array of promises as its argument, and it returns a promise. So we can do .then on that. Yeah, let's say value, and let's console log the value here, value. Okay, now as you can see on the right side in the terminal, we get an array of values. Okay, so the way Promise.all works, it tries to resolve all the promises, right? And if all of them resolve, it returns an array of values in the same order that you provided your promises. Now, if I would just reorder our promises, and I would say promise.result2 is the first element in the array. Now I would get 2, 1, 3, 4. Okay, so 2, 1, 3, 4. So again, Promise.all resolves all these promises in the array and returns, and in the .then consumer, the value would be an array of values of resolved promises. Okay, yeah, you might think, why may we need this? Now, a very real world application of this for me that I use all the time is to make multiple network requests simultaneously. Now, the way this Promise.all works, it does not kind of resolve this one and then resolve this one and then resolve this one and the fourth one. So it does not work in the sequence, but it kind of starts to all these promises are being worked at the same time simultaneously. So this is the power of Promise.all, and it will always guarantee that if all of the promises are resolved, you will get your value in the .then, and the values of these promises will be in the same order that you specified your promises in the array. Okay, now when I say these promises kind of execute simultaneously, right? So that means imagine you have a network, you're making 3 independent network calls. Okay, so you get a user, you get your user's data. Imagine you have a user ID, right, in the very beginning. So you need to fetch the user data, you need to fetch some kind of other details which are not in the user data, and you maybe need to fetch some kind of configuration object or whatever it is. I'm just making up an example here. And you can of course fetch the user object first, then fetch the user data, and then fetch the configuration object. However, in this case, this HTTP request, this network requests do not kind of depend on each other. So they could have made, they could have done simultaneously at the same time. And that's where Promise.all comes into play. And you can say fetch, just making up an example here. You can say fetch the user, and you can say fetch user data, and then you can say configuration, right? Now, all 3 of these, and imagine this fetch function returns a promise, okay? So when we call it with this URL, the fetch function will return a promise. So we have 3 promises in an array, which we give to the Promise.all, and all of these network requests are done simultaneously. That's how Promise.all works. It doesn't matter if it's network requests, whatever promises they are kind of trying to be resolved simultaneously. So we will start doing, so instead of doing this /user then let me go for a comment here, /user then /user data, and then request configuration. What you can do is /user data /configuration. Now, this is the sequential kind of call of the network request, right? So we fetch user data after we fetch user, and only the user data was fetched successfully, we fetch our configuration. And now with Promise.all, we can fetch all these data simultaneously. So that saves a lot of time. In these cases where these asynchronous promises can be resolved simultaneously, of course, or are independent. Now we're going to come to our example .resolve 1 and 2 and 3. Now, as you noticed, I do not have a .catch there. So if I would put a .catch here, it would never be, sorry, error, error. Now, this dot catch, given this code, will never execute because we just we give an array of already resolved promises to Promise.all, so that then will always be invoked. Now, what happens if one of the in real life, of course, promises not always resolved, so we might have also some error cases. Now, what happens if one of the promises is rejected? For example, we have promise.reject, not resolve, but reject. New error. Now, when any one of the promises rejects, the whole Promise.all will reject, okay? So now the way this works, we try to resolve all the promises simultaneously, okay? But if one of the promises rejects, that means the whole Promise.all rejects too. Now, if I would save this, as you can see, error, hello, we get this console log. Promise.all is rejected. Let's put this way. Okay, so Promise.all is rejected, and this is our error. Cool. So let me clear the terminal again, run it one more time. And again, Promise.all is rejected with our error. So this is how Promise.all works. It tries to resolve all the promises simultaneously. However, if one of the promises rejects, the whole Promise.all will reject too. Now, of course, if say some of the promises resolve in 1 second and the last promise resolves in 10 minutes, the whole Promise.all will of course also resolve in 10 minutes because it awaits for all the promises to resolve. And if any of the promises rejects, the whole Promise.all rejects too with the error. So I hope this makes sense. So it means either all promises resolve, and then we can use the dot then consume to receive an array of values of the resolved promises, or in case any of the promises, doesn't matter which one, any of the promises rejects, the whole Promise.all call will also reject. So a very important characteristic of Promise.all, it always awaits for all the promises to resolve. Again, so if we have 5 promises, 4 of them resolve in 1 to 2 seconds, and the last one resolves in 5 minutes, the whole Promise.all, Promise.all will await for the last one to either reject or resolve. If the last one resolves in, say, 5 minutes, then Promise.all will resolve. We'll be able to use the dot then consumer. If if that last promise rejects in like 6 minutes, whatever it is, the whole Promise.all will also be rejected. Okay. So that's the way Promise.all works. Now let's see what Promise.race is. And as you can see in the IDE, it also expects to receive an array of something, right? It's usually an array of promises, and it returns a promise itself. So again, let's go with our array. Let me just format this really quickly, like this. And it returns a promise, as we have seen. Okay, so let's see what the value is in this time. Console log value. Let me maybe comment this out like this. Kill the process here, and then npm start to to have a clear terminal here. Okay. Now, now it's kind of interesting with Promise.race. Okay. So as you can see, each time I save the file, right? As we can see with this part being logged, that means I save the file and the whole index.ts file is rerun again. So every time I save this, it still gives me the same result, which is 1, 1, 1, which is the result value of this first promise. And by the way, that's actually how Promise.race works. So it gives you the value of the very first resolved promise. So in this case, the first resolved promise is our first promise, you know, on the line 0. And if I would change the order of my promises, what is this? Okay, sorry. So now I change the order of my promises in the array. Now the first element in the array is promise resolve 2. And of course, remember that promise.resolve always returns a promise which is resolved, which means that all of the elements, all of the promises in this array will be resolved. However, that also means in this case that the first element of the array will be always resolved. Hence, Promise.race looks at the very first resolved kind of promise in your array of promises and gives you the result of that promise in .then. So it does not give you an array of values that like Promise.all does. It just gives you the value of the very first resolved promise. Now let's have a .catch in here again. And I will do this. I'll put it here and I'll say promise.race is rejected. And let's have also another promise.reject somewhere in the middle. Now, as you can see, there's a big difference between Promise.all and Promise.race. It's kind of interesting, but I have a promise here in the array of promises which always rejects, right? Because I said promise.reject, blah, blah, blah. So promise.reject always rejects. There is no other options with promise.reject. But interestingly, I still don't have this catch being called, right? So now this is interesting with Promise.race. You should remember that it kind of just returns the first resolved promise, and if there is any promise that is rejected, it basically kind of doesn't care. Now, an interesting thing would be to see the case if all promises are rejected. Okay, so now we have an array of promises and all the promises are rejected. Now, this is the case where .catch is .catch consumer is invoked. Okay, now again, very big difference between Promise.all and Promise.race. So in case of Promise.all, it resolves only if all of your promises are resolved. If there is any one promise which rejects, the whole Promise.all rejects too. Now with Promise.race, if there is any one promise which resolves, that value will be available in the .consumer, despite that you have some other promises which reject. Now, and with Promise.race, it's vice versa. So Promise.all resolves only when all the promises in the array resolve. And now with Promise.race, this Promise.race rejects only when all of the promises in the array argument reject. So they work kind of very differently. Again, if you ask me why would I need to use Promise.race, I honestly cannot answer that question. I've never really used Promise.race in any of my projects. Maybe just played around to see how it works and to get the idea how it works, but never got a chance to actually use it. So maybe one case would be, I'm just trying to think of an hypothetical case, right? So imagine you have 5 databases or 5 backends. And we have, and there are replicas, which means the data in these backends, in these databases are kind of the same, okay? And imagine these databases or servers are located in different parts of the world, and you just need to get the data from any of them, right? So whichever responds with the data, you want that. So since these servers are located in different parts of the globe, some of them might respond quicker, some of them might respond slower. So you just need to get the data from the fastest server there is. So you have the list of your servers, right? So you say Promise.race fetch, I don't know, server 1, and then you say fetch server 2, server 3, server 4, server 5, whatever, we don't care. So we're making the same request to 5 servers. All of them return the same result. However, they are located in different parts of the globe. So some of them might respond quicker, some of them might respond slower, some of them might just give an error because there is some kind of error in the server itself, whatever it is. So now imagine that this first one rejects, and this one also rejects. Okay, and the third one resolves. Resolves. Now, when this one resolves, despite the other 2 being resolved or not resolved or rejected, we don't care. The result of of what we get from server 3 will be in the end consumer. Okay, because this one resolved first. This one just resolved faster. Resolved faster than others, and this one also resolved, and this one also resolved. Okay, so 2 of them rejected, 3 of them resolved. However, this the fetch, the get request, the HTTP request to the third server resolved much faster than the other 2. So we will have the result of this fetch server 3 call in the .then. And that's what we're basically kind of interested in this case, right? So just we have the guarantee that all the data coming from these 5 servers is the same. We're just interested in getting the data from any of them as soon as possible. The faster, the better. So hence, when server 3 resolves faster than the others, we will have the result of server 3 in our .then. Now imagine that all of them reject. There is a problem with all of these servers, right? So in this case, we do not have any response from the server, from any of the servers. All of them reject. There is a problem with all of them. That only in that case we will be in the .catch where we actually should be, right? So there is no successful response by any of the servers. Hence, we will have to be in the .catch. So this is, again, exactly how Promise.race works. If any of the promises resolves, the result of that promise will be in the .then. If all of the promises reject, the result of the rejection will be in .catch. Again, this is an example. I just came up right now. This might be a real world example for some of the servers, right? So this was what I could think of, right? So I'm just trying to make the same HTTP request to different places, and I just need a fast response from any of them. And if all of them reject, then I don't have a success response. So my Promise.race should also reject. So this could be the answer to your potential question: why would we need to use Promise.race? But again, I've never really used this in any of my projects. Just played around to understand how this works. But again, this example that I brought, I can imagine that this could be a real world example for some other products, some other projects. So of course, since Promise.race exists, and there are definitely use cases for that. So you can look up in the Google to see where you can use and why would you use Promise.race. Again, Promise.all is something I use all the time, really all the time, because and especially with network requests, I just kick off the network request simultaneously. Usually I require all of them to resolve. If any of them does not resolve, then I will do some fallbacks, right? Provide some default values or show an error message, something like that. So for me, really, Promise.all is usually what I use. I never use Promise.race in my real projects, but I can imagine there are use cases for Promise.race because it exists. Okay, so that was Promise.race. Any questions so far?
Just wondering if the first line would be rejected, we will still see the resolve one, right? With the raise, it is waiting for the first resolve, not looking into the first line if it is rejected or resolved and bring that up, but it's bringing the resolved line. I mean, in our example, the first line was resolved and we saw it is printed logged. But if it was, even if it would be rejected, we will still see the first resolved one, right?
Yeah, that's correct. That's how Promise.race works.
Okay.
Now, since we have some time, some 16 minutes or so, let's also see how Promise.all.settled works. So I'll start with Promise again, .all.settled, right? And let my IDE again suggest what all.settled receives. Okay, so again, whenever you are unsure what my function, what kind of arguments my function receives, how did Promise.all, how does Promise.all works, just rely on your IDE, okay? Because it usually just gives you hints. So I just typed my parentheses, right? Even if I would not know, or even if I would not remember how all.settled work, my IDE is of help here, right? So rely on your IDE here. So I typed the parentheses here, and my IDE promptly, and a pop-up in my IDE promptly appeared saying that all.settled has one argument and one argument only. They call it values in their case. So we can call it whatever we want. Doesn't matter. And it is an array. Okay. And what does that return? And it returns a promise of a race. Okay, interesting. So it receives again an array, an array of promises, of course. We're talking promises. Now let me grab this with this, copy all this array here, comment this out, and comment this out. And let me bring this here. Now let's write both the then values, since we've seen that it returns a promise of an array of a promise which resolves to an array. So I'll do console.log values. And let me also bring this same catch here. And now I'll say promise all.settled is rejected. Now let me save this, and we get a lot of things in the terminal. Let me clear this, save the file again. So let's kind of try to see what's going on in the terminal. Now, of course, the Promise.settled is rejected was not called, as we do not see that logged in the terminal anywhere. So the then was called. And interestingly, as you can see, we have a promise.reject here. Now, this Promise.all.settled works kind of similar to the .all, meaning it returns in the .then consumer, you will have an array where the result of your promises will be will have the same order. So if we would just change the order here in the argument of all settled, and let's look to the right side in the terminal, we have status fulfilled 1 and status fulfilled 2. Now, if I save their order will be also changed, as you can see here. So the first element is status fulfilled value 2, as we have our promise with value 2 as the first argument, as the first element of the array. And so yeah, in that case, also in that sense, all settled works like similar to Promise.all. So in the .then consumer, it will give you an array of values in the same order that you have your promises. Now the interesting thing is the third element in the array, which is the promise reject. Now, interestingly, as you can see in the arrays, in the resulting array, we just don't have the values themselves, but we have some objects, and these objects have two keys, status and value. So this object basically represents the status of our promise. So if the promise resolves, we have the successful case. The status of the status key, the value of the status key will be fulfilled, basically meaning that your promise was resolved, and here is the value of your resolution, of your resolved promise. Now, the first element of the incoming argument is a result promise with value 2. The second one is again a result or fulfilled promise with value 1. Now, the third one is the interesting one, because we have a rejected promise there, and with an error. So now when a promise is rejected, the status will be also rejected. And in the reason key, not in the value, but in the reason key, we will have the error. And the fourth one again is also a resolved promise. And that's why we have status fulfilled value 3. Now let's see what happens when we have only rejected promises. We have hello 1, hello 2. Let me just clear the terminal and save. Okay. Now, again, as you can see, now the difference between all settled and the .race is that with Promise.race, if all of the promises were rejected, then we could consume the error in the .catch. But with all settled, again, we have only rejected promises, but still the .catch was not called because we do not see Promise.allSettled is rejected in the terminal. Okay, so all of our promises in the incoming argument, the array of promises, all of them are rejected, and in our .then consumers, we still have an array of objects, and the status of all of these promises is rejected, and the reason is the error messages that we have in our promise.reject. Okay, so the way you would use this .allSettled is that if you would not like your Promise.all to throw an error, right? To just throw an error whenever any of the promises is kind of rejected. So you are basically interested in both the result values and the errors. So that's when you would use allSettled. You would then go through your array in .then and just check if the status of the promise is fulfilled, then process that value. And if the status of your promise is rejected, then maybe log the reason there. So as you can see, we've tried a couple of cases, and Promise.allSettled kind of never rejected. So we never the line 100 here, the .catch consumer was never basically invoked. So we were always in the .then. So that's kind of the purpose of allSettled. So it does not throw an error. So we cannot. So we don't use rather the .catch consumer. We will always have this .then consumer available, and the statuses of each promises in the same order that we have in the incoming this argument array of promises. the objects, the results of resolution or rejection will be in the same order. And then you can maybe just loop loop over your values and process somehow your promises, whether you'll see whether they're rejected or they're fulfilled, and then you can do something based on that. Okay, so that's all settled. Maybe let's try to pass something that is not an array. So as you can see, TypeScript kind of tries to warn me here, and I guess it will not allow me to compile the code. So maybe there is a way to kind of somehow get into the .catch consumer here. But again, if you provide an array of promises or an array of why is my terminal not being cleared? Okay, whatever, never mind. Yeah, you can have, of course, you can have like in the .then, similar to what we have in .then, you can return promises, you can return kind of normal values, whatever they are. You can also pass like primitive or non-primitive values in your .allSettled, whatever they are. You can have 12, you can have a string, hello, you can have an object here, right? Key value, right? And then we can have a rejected promise, and all of this will be actually there. As you can see, the first element in the result of the .then consumer is a fulfilled promise. So we have a primitive value here. However, in the .then, the first kind of object represents a fulfilled promise, right? So again, you can have promises here. You can have other types of values. If you have a normal value like 12, you will just immediately have that. So imagine that this is wrapped with a promise.resolve. Resolve. Yeah, imagine that this is wrapped with promise.resolve in this case. So the result is kind of the same. An interesting case would be if you would just pass an error object here, right? Let's say error 1. And if we save, now the interesting case here is, right? So we created an instance of the error object. Again, it kind of returns a promise which is fulfilled. Okay, so you might kind of expect that if I would create an error here, that would be recognized as an error. No, it does not it's not being recognized with an error, because all of the plain values you can imagine are being kind of wrapped with promise.resolved. And so this is hello 2, and where is my hello 1? Yeah, this is hello 1. So again, fulfilled. So all of your primitive values, non-primitive values, all the values that are not promises, imagine they are wrapped in promise.resolve. So you can either say promise.resolve 12, or you can just say 12 in your array of arguments. So that basically results in the same thing. And this is true for Promise.all.settled. This is true for Promise.race, and this is also true for Promise.all. So you can not only use promises there, but you can also use other values which are not promises, and these values will be resolved immediately. Okay. So let's have a comment here. Never executes. All right. So any questions? We have a few minutes left. So if you have any, I'll stop here as I covered all the topics for today. I hope you learned how to convert a callback asynchronous function into the promised version of that, how working with promises is different with working asynchronous callback functions, what Promise.all is, what Promise.race is, when to use what are the use cases of them, right? So what the Promise.all.settled is. So I hope all this is a bit more clear now. So we have only a couple of minutes left. If any questions, please go ahead. Otherwise, we can end the call for today.